Hello, my name is Hamilton Payne. I'm a Georgia Tech student, and I'm going to go over this problem that we recently had for Georgia Tech's Physics 2212, which is the electromagnetism part of physics. So, we have this problem right here. I'm going over this problem because I actually experienced a good amount of difficulty from it, and I think that with what I've learned from the parts that I've missed, this should help other students who are going through problems like these, and this problem is pretty difficult, to understand things conceptually, to not necessarily memorize equations, because that's a big thing. So the problem itself, in case you haven't already read it, it says that a tiny scrap of paper suspended motionless below a plastic pen that carries a net charge of Q. So we're looking at a single carbon atom, and the center of its outer electron cloud shifts a distance s when the carbon atom is polarized by the pen. So we have different amounts of statements. The first one is the net force is 0. This for A and B of this problem, it actually wasn't quite as hard. So we're just going to run through those real quick. Net force is 0 because it's suspended motionless, as it says. And then the forces that act on the carbon atom are the electric force and the gravitational force. As I put on my paper, they actually cancel each other out, and that's the only way that it can truly have an E net of 0 where it's suspended motionless. So here's where it gets a little shaky. So the thing is that you need to understand the equations for electric forces to use this. And with us, we were given a formula sheet, so I can go over any of the necessary equations, but we didn't have to memorize anything, again emphasizing that it's more important to understand the concepts than to actually just memorize equations and think they'll apply in every situation. So here we have the momentum principle, Newton's second law. We're trying to find S. This is a separation distance between the dipole that is created by the electron cloud and the nucleus in the carbon atom. So as the instruction says, there are different constants. The pen charge Q, mass of the carbon atom M, acceleration is G, and so on. So it's important to remember that the forces are equal, so Fg is going to equal F electric. For that wasn't as difficult for me, but a lot of people tend to miss that. So Fg, Mg, as it says on the paper, right here, and then right next to F electric. Now the distinction, here's what I missed. This is a dipole. This is a dipole created by the polarization of the carbon atom. So what we need to understand is we're given the formula for a dipole on the formula sheet that we're given. It's important to put things in terms of that. So you have 1 over 4 pi E naught. That's obviously necessary. But also, when you're looking at the charges and you're looking at the forces, the electric field for a dipole when it is on axis, which is the case of this, it's not perpendicular, it's going to be 2 times q times s over h cubed times k, which is 1 over 4 pi to the e naught, 9 times 10 to the ninth, essentially. In this, I missed it. I confused it with the normal equation. You can't do that with dipoles. It's important to know it was very specific in noting that it was polarized, and so it creates a dipole, and you can understand that because also it talks specifically about the distance s. So that's really one of the biggest things I missed. Now, with that in mind, what you want to do, you want to take that net force. It's going to be F electric minus gravity, because F electric, we're saying it's positive in this case, and that means by default the force of gravity is going to be negative. So you just, in this, like I did, you have to subtract the force of gravity from the electric force. And right here it says, when my paper was corrected, that was changed to h cubed because that is what I missed. And so it's important to use the right equation. That's one of the biggest lessons from this situation. So we have 1 over 4 pi E naught. The end equation is, this is another part, you set them equal. That's very important. You can do that because, like we said before, the net force is 0. So the forces, since there are only 2 forces, they have to be equal they have to be equal, or the components have to add up to 0, basically. Yeah, so this is simplified. Of course, it's going to be mg pi e naught h cubed, and then 2eq. Honestly can't read that. I'm not going to lie to you. I can't read that. But you get the gist. Looking at it, you use all the necessary constants. You have big Q. It's very important for this case, for the little q, the charge of the carbon atom, to substitute the negative 4e. And then the rest of it is just take all the other constants. You kind of just divide and multiply until you set s on its own side, and so you get the equation that you want. And going on, it extends this to polarizability. So another thing is that people might have missed is, even if they got the separation distance right, this equation is even more complicated. So using your result for S and applying the same procedure from your WebAssign homework. WebAssign is a tool that we use to do homework. So you derive an algebraic expression for the carbon atoms, polarizability, alpha. Use the symbols as necessary. We're using the same symbols. So keeping that in mind, we have the equation right here. A1 E2 equals Q1 S1. So that just basically means the polarizability times the polarizability of one atom times the electric field of another atom on it is going to equal the charge times the separation distance. And so we know what S is, and then we also know what Q is. With that, all we have to do is just take all these equations. We have E of external. The external is going to be the pen. So that's a regular equation. It's important to distinguish that that's actually not a dipole. That's just a normal equation that you can use. And from that, you factor that in. To get alpha on its own side, you divide that to the other side. You multiply it by Q times the separation distance, and so you get the equation on the bottom, which is pretty messy, but you should be able to work it out pretty well. And so if you look at it, you have E2 is inversed because you divide it on both sides, and then you have Q times S, which actually is pretty straightforward. The distinction being that, what else? Anything else that I missed? Nope. It's good. Yeah, you can cancel out for most of these things. So in the end, you end up with 8 mg pi squared E naught squared h to the 5th over q squared. H to the 5th just carries over from the original S, where this should have been h cubed. And the rest of the math is very important to watch for clerical errors, and especially propagation of error. The thing is that I'm going to speak from an engineer's perspective because I'm an engineer. When you're an engineer and you're applying things, there's no, I get this percentage of a grade, or whatever. It's not like you get a 70%, 80%, 90%. It's you either pass, you either get the equation right, or you fail and you have to go back and do it again. So it's very important to get these equations right, which means hammering down the concepts is an important thing for colleges to do. Now, you should not necessarily fret if at the moment you can't understand the things. It's important to use the resources you have and talk to people that you know that understand these concepts, and just hammer it down, and then working on these problems every once in a while can be pretty useful. And so in the end, I missed a little bit. I could have honestly missed more. I got 13 out of 15 for that section, and I actually got the first section right. So I didn't even miss that much, even though it was a difficult problem, because I made sure to draw my little Fury body diagram in the first part. That helped a lot. And then I guess there's this diagram, which wasn't super helpful. But anyways, yep, that's all. Yeah, peace. Thank you so much for watching.